Okay then guys, this section deals with problems involving moduli. That's the plural of modulus when we say moduli. So here's a modulus x function here. Here's the definition of what it is. It's equal to the value of it. Here, you take the positive. If it's positive, greater than or equal to 0, you take the value itself. If the number in the modulus is negative, then you flip it to a minus. If it's negative, you make it a minus. So in other words, another phrase that's interchangeable with the modulus is the absolute value. This is the absolute value function. In other words, you drop the negative if there is one to drop. And it corresponds to the distance away from the origin, really. So if you think about a modulus, say, of 5, that has a distance away from the O on the number line of 5 units. Similarly, the modulus of minus 5 is a distance 5 away from the origin, isn't it? From the 0 point on the number line. So I hope you can see that intuitively. If you're drawing a sketch of that modulus function, it comes out like this. And in practice, the way to draw that, what we generally do when we draw moduli is the first thing we do is we draw the thing that's inside. So if you have a axis, let's just do a quick sketch. If we were to draw the line, I'll draw it as a dotted line, y equals x is there. If you take the modulus of that function, the modulus of y equals x, this is y equals x, then any negative values have to flip up to be positive, so it's like taking a mirror image. And in practice, this is how you draw the modulus function. So now we've got the modulus function here, haven't we? But we got it from writing out y equals x first and then reflecting any negative values through the x-axis here. And that's in practice what you do. So if you had, say, the modulus of 2x minus 3, that modulus, and you wanted to sketch it, well, let's have a go at that then. 2x minus 3 is a line of gradient 2, intercept minus 3, isn't it, if you look at the thing inside? So let's just draw that as a series of dashed lines. This intercept would be minus 3 here. Gradient 2, and it works out when this equals 0, x is equal to 3 over 2. That's when it's 0, isn't it? 3 over 2. And so then you reflect this line up here through the x-axis. And there's your modulus function. So now we can drop the line that we drew originally so that we could see what was what. And that value there, of course, when it's reflected becomes 3. And this now is the modulus function. So that's the process which we go through in order to draw moduli on xy axes. And in principle, they should be no more difficult than that, really. If you're drawing a quadratic, say like x minus 1 times x plus 1 then, suppose we have that, that's a U-shaped curve, isn't it, with roots 1 and minus 1. And minus 1. And then if you're drawing the quadratic, it would come down, go through, and then come back up, reflection, through the y, it's symmetric through the y-axis, isn't it? Because of the roots, equally spaced either side. Now if you're drawing the modulus, well, these values are fine, aren't they? This value here is fine, if I can try and draw it. That value is fine, but these negative values, to take the modulus of them, you'd have to reflect it. So that's the sort of shaped curve you'd end up getting if you were to take the modulus of the quadratic function. So in practice, we would draw the quadratic function first, and then any negative values that would occur, we reflect them through the x-axis. So again, that's the process, that's what we do when we're drawing these things. So these problems in this section involve moduli, lots of problems, but in essence it's an awful lot of curve sketching involved and then interpreting a modulus in terms of its inequalities. So if the other thing we do is if you have, say, 2x is less than 7, that means the size of the number 2x is within a distance 7 of the origin or on the number line. Well, that is what we mean. It's this 2x is within a distance either side of 0 of 7 units. So it must be greater than minus 7 and it must be less than 7, mustn't it? Here's 0 on the number line. Here's the minus 7 and plus 7. So 2x, the modulus, the size of the number, any size of the number to be less than 7 must lie inside here, mustn't it? Are supposed to be equal both sides, that. Not drawn to scale, of course. So that's what you get. And then once you've reinterpreted what the modulus is in terms of an inequality, then you can use all the operations on inequalities that were used in the previous section. So anything more really is best explained by examples. So all the best in this section then, guys, and I'll catch you in the next one. Cheers!